Hello. In today's daily lead code challenge, the question is maximum sum circular subarray. So here we are given with a circular integer array nums of length n, and we have to return the maximum possible sum of a non-empty subarray of nums. So what it basically means is that the array is connected from end to beginning. So you can say that it's a circular road where all the array are on the road, and we have to iterate over all the array accordingly. So what we have to do is we have to return the maximum sum of that subarray. So basically in the cadence algorithm, what we do is, like in the maximum sum subarray algorithm, what we do is we have to calculate the contiguous maximum sum of that array. But here this array is special because here the end is connected with the beginning of the array, and here it is also mentioned that we don't have to consider, and the array is not getting overlapped when we like connect them into beginning. So in this statement you can find that. So looking at the current examples, so in the example number one we are given with 1 minus 2 3 minus 2. So as you can see, 3 is the maximum sum subarray for this example. But especially for this example you can see that the answer is 10 here. So how it is 10? So here we can remove this 3 from the array, and what we can, and this special array is connected from into beginning. So this 5 and this 5 is contiguous for this array, therefore this 10 is result of these two. So what we can see that we can also remove the minimum so far of the array to the sum of the sum of the sum. Like we have a liberty to do that, to remove the maximum sum minimum sum sub array from the array to get the maximum so far. So especially what we have to do here is that not only we have to calculate the maximum so far of the array, we also have a liberty of removing the minimum so far into the array. So if minimum so far getting extracted from my array, and if I found the sum of that array, so if that is greater than the maximum so far, so I can say that I get a circularly connected array which have a sum greater than the current sum maximum so far if it is a 1D array, or if it is a like a normal array. So here what I have done is I have initialized all these variables with first number of the array. So what I have done here is that I have initialized all this variable with the first element of this array, and then I have calculated current max and maximum so far and current min and maximum so far. So whenever I find that minimum so far equal to my sum, that means that all of the elements are negative here. So you can see that example here. So all of the elements are negative here, and min so far will be like the sum of the array, right? So minimum so far would be, if minimum so far equal to sum, I will return the maximum so far, and after that I will look into the maximum of maximum so far minus comma sum minus maximum so far maximum of them. So here we have to check whether we have to continue with the same like continuous subarray we are coming from, and we have to start the new subarray. So here we don't need to compare the current max. So let's try to run it. So all the test cases are passing here. Let's try to submit this question. So it got accepted. So time complexity for this question is big O of n, and a space complexity is constant because we are not using any extra space here other than these variables which are constant in size. So I hope you understand my approach and like this video. Thank you for watching this video. See you in the next one.